This is a problem with 2D support reactions where we have a fixed support at A and we have a distributed load that's on the bar AB. And so we're asked to draw the free body diagram and then get the support reactions at A. All right, let's see what we need to do. Well, the first thing we should probably do is take that distributed load and turn it into concentrated force. So we can say R is equal to, it's a triangle, so area of triangle is 1/2 times the length times the height. The length would be 18 meters. And the height would be 20 newtons per meter. 20 divided by 2 is 10, so we get 180 Newton. That's easy. Then X bar, we have a triangle, but we're not going from the tip, we're going from the other side, so that would be just 1/3 times the length, 18 meters, and that is 6 meters. All right, with that we can draw our free body diagram, but let's do that on the next page. It's getting a little crowded here. All right, so if we're gonna do this, then we'll have our bar, and we have a fixed support here at A, which means that we have the two forces in the X and the Y direction, and we'll have a moment. So let's draw that in. This will be our bar. We know that we have a force coming downward. That's our concentrated force. Be somewhere here. That would be R equal to 180 Newton. We know that this distance is 6 meters. And then we have our support reactions, right? We have a Y. We'll have a X. And then we have a moment, so we'll call it MA. And we'll say we define it positive as counterclockwise. MA. And that's all we have. Maybe we'll put in that this is point A. Although pretty clear with all the A names there. This is point B. Although I don't think we're going to need point B for anything in this case. And of course our coordinate system, X and Y. All right, so that was point A. So point B is just to find all the support reactions. B. All right, so again, we want to choose them in a way where we only have one unknown at a time. So what can we do there? Let's see, if we want to have one unknown at a time, I think it doesn't matter, right? If we do a X that we want, a Y we want, and M, all of them are easy. So this one is a straightforward one, right? So if we do sum of forces in the X direction equal to 0, well, we only have AX going in the X direction. So that means no force in the X direction. If we say sum of forces in the Y direction equal to 0, well, then we get AY positive upward. We get R going downward. So that means AY equal to R equal to 180 Newton. And then of course we still need to find our MA. So maybe we can do the sum of moments around point A. It's going to look a little strange. MA is equal to 0. So we said we defined MA as positive, so MA. And then we'll have R is turning clockwise, so negative, minus R times 6 meter, because that's the moment arm. AX and AY both goes through A, and there's nothing at B, so that's all we got. Again, a single shot, you can say. So that means MA is equal to R, which was 180 Newton times 6 meters. And that gives me 1,080 meters, Newton meters. Newton times meters. and it is positive, so we can say it's turning counter clockwise. And with that, we have our 3 support reactions. That was very easy. Now, if we wanted to do a test here, right, then we would do a moment around B, and we could get a result there, but we'll skip that for this time. All right, so this was a problem with a 2D support reaction where we had a fixed support at A and then a triangular distributed load.